3 moles of the, each mole of acid requires 3 moles of the base there. So this molar ratio times the number of moles of the base that we have here will give you the number of moles of acid. If you know the number of moles by definition is gram per over the molar mass there. Okay? So in this case, number of moles is figured out. And the total mass of the sample is given. Molar mass is the N now. Okay. Now we figure out the molar mass to be 98.2054. So this is another type of calculation that you will see. Okay. So as you can see, learning objective 4 is the topic that will cover many different types of calculations there. Dilution, titration, percent composition analysis, identifying molar mass, and with the introduction of the molarity, these are the types of calculations that we need you to be able to do. Okay. Another topic we want to assign you as a self-study topic there. In chapter 4, we introduce many different types of chemical reactions there, such as acid-base reaction, gas-forming reaction, precipitation reaction, oxidation reduction reaction. Now many of these types of reactions are kind of self-explanatory. When you read through the textbook there, you will understand what is a precipitation reaction. Well, when you mix 2 things together, you generate something that's insoluble. That's a precipitation reaction in water. Okay. Acid-base reaction, we talked about many of the acid-base reactions in the previous learning objective there. So when you have an acid and a base and mix them together, you end up with salt and water. And we can do calculations there. And gas forming, if you mix 2 together, a particular type of gas is being generated. Say if you have zinc mixed with HCl, hydrochloric acid, hydrogen gas is being generated. Baking soda mixed with vinegar, carbon dioxide is being generated. So gas forming reaction means gas is one of the products in the chemical reaction. Now we want to single out one type of reaction, oxidation reduction reaction. Okay. We want you to be able to, we want to look into the oxidation reduction reaction because there is a particular thing changed in that type of reaction we call oxidation number. And we'll single out that. And everything else is pretty much a self-study topic there. So make sure you know, you need to be able to write out the products of precipitation reaction, acid-base reaction, gas-forming reaction there by going through the textbook there. And one thing that I will not emphasize for now, but eventually you will need to memorize is the solubility rules there. When you mix 2 different types of components together, what is water soluble? What is not? For now, you don't need to memorize this table for the final exam. You will have to memorize this table. Now, ultimately, when we ask you to memorize certain things there, in the regular in-class exam, you are not allowed to take any notes with you. In the final exam, we do allow you to take 1 index card. So for the information that you don't have time to memorize, thank goodness I don't. And you can put this information on that index card. And whenever you run into a question that tests you on the solubility, at least you have that information. If you click on final exam now on Canvas there, you will see a PowerPoint slide. And that is the slide that I used for my Chem 102 class, very much similar to this table there. So in general, when you have lithium, sodium, potassium, group 1A elements, and ammonium, NH4, okay, when you have anions like these, no matter what they combine with to form ionic compound, they are water soluble. There is no exception there. When you have nitrate ions and acetate ions, acetate, kind of reserve on that because I know silver nut acetate is not water soluble in large quantity there. But nitrate, NO3, everything nitrate is water soluble. There's no exception there. So this is the table that we need you to glance at least for now. And eventually, when you study for the final exam, we will come back to this particular slide. And we'll show you this particular slide. If you want to memorize everything, great. If you don't, well, at least we do give you an option of putting it on a piece of index card, and you can take the video to the final exam with you. Okay, so that's how much we want to talk about for the different types of reactions involved in chapter 4. Again, self-study doesn't mean you won't be tested. And you may not be tested on the in-class exam, but in the final exam there, you will see oxidation reduction reaction, acid-base reaction, and the solubility rules there. So make sure you take the time when you read chapter 4 there, make sure you take the time, go through those details there, and try to remember as much as you can. The last topic of this chapter, we want to take a look at oxidation reduction reactions. I know I don't have a whole lot of time. My official ending time for this lecture is 10:15, so we'll try to stop at 10:15. We'll try to do as much as we can to 10:15 here. So the last learning objective, we need you to be able to assign what we call oxidation numbers to atoms in a molecule or ions, and be able to identify in the redox reaction, oxidation reduction reaction, be able to identify who is being oxidized, who's being reduced. Okay, so that's the topic there. And why is this type of chemical reaction so important? Well, because many of the reactions we experience in everyday life have something to do with the oxidation reduction reaction there. So in this case, what is redox reaction? Acid-base reaction, well, it's an acid reacting with base. Okay. A gas-forming reaction, the reaction that produces gas is one of the products. Precipitation reaction, the reaction that generates something that's not water soluble. But what's redox reaction? Here's a well, redox, by the way, is not an English word, it's a chemistry word, and we combine oxidation, which is English, and reduction together, redox. Okay. And here's an example of redox reaction. Whenever there's oxygen gas involved, it's a redox reaction. If you have hydrogen gas, you have oxygen gas, and you line it up, and you end up with an explosion here. So that's a redox reaction. However, oxygen does not have to be always a part of redox reaction. Okay? So in this case, and we give you some examples, anything that happens in your battery, rechargeable battery, dry cell battery, anything that happens in the battery, you're basically converting chemical energy into electrical energy. Okay? Some of the reactions are reversible, like the rechargeable battery there, your cell phone, your laptop. Okay. And when the chemical reaction is finished, there's no more electricity can be provided from there. You plug it into the wallet, outlet on the wall there, you recharge them, you reverse the chemical reaction. So redox reaction happens in batteries, okay? And this is also something that you see on a regular basis there. And when you build a deck there and you put a metal nail with iron in there, over time the moisture in the air and the iron react with one another, corrosion happens. When you burn fuse, gasoline or natural gas, that's a redox reaction. When you try to refine metal from metal ore, that's a redox reaction. So redox reaction is closely related to our daily life. And examples of redox reaction. Well, we have oxygen gas reacting with hydrogen gas. Anytime that you have oxygen gas involved, that's going to be a redox reaction. By the way, oxygen is going to be your oxidizing reagents. Okay, something to remember. So that's one example there. Another example of redox reaction. If you have silver nitrate, which is an ionic compound, if you dissolve silver nitrate in solution, okay, you form a clear, transparent, single-phase homogeneous mixture there. If you dip a copper strip in there, over time you will see copper start to dissolve into the solution. In the meantime, on the surface of the copper strip, and you see silver metal start to